workers, in this lesson we're going to continue our study on radicals, and in particular we're going to be just focusing on square roots in this lesson. Now, the operation that we want to do with these square roots is division. So we're going to be dividing radicals. Now, you divided radicals before, and so let's kind of review that idea from before. So this is going to be a review from a previous lesson. And in that lesson, you were asked to divide, and um, and remember, when you're dividing radicals, you're going to need to make sure that you simplify as well. All right, now it'll just say divide, and it's going to say something else in a little while. But in the previous lesson, in previous lessons, you were just asked to say the operation was just to say divide. But remember, when you divide radicals, when you're dealing with radicals, you have to make sure that you simplify as well. But let's review something we've had before. So this is going to be our problem in terms of the review. Let's suppose we had the square root of 28x divided by the square root of 25. All right, and you had something like this in a previous lesson. So if you look at the denominator, let's do the denominator first. So the square root of 25, 25 is a perfect square, so the square root of 25 is 5. Now let's talk about the square root of 28x. So we're going to simplify this. And so the square root of 28x, I'm going to go ahead and rewrite it. Now remember, based on the product rule for radicals, that's the square root of 28 times the square root of x. And then the square root of 28 we can simplify because the largest perfect square that goes into 28 is 4. So we get the square root of 4 times the square root of 7 times the square root of x. And the square root of 4 is 2, and we know that we cannot simplify the square root of 7, and we cannot simplify the square root of x. But we need to rewrite this because we know that according to the product rule, whenever the indices are the same, I can write it as one radical. So it'll be the square root of 7x, just multiplying the radicands together. So that's a 7 right here. And so the numerator then becomes 2 square root of 7x. Okay? Now here's the idea with the new with our new lesson. So with this lesson, suppose we had this, and I'm going to leave the directions off right now, but let's suppose I had number 1. Let's suppose we had we had 5 divided by the square root of 2. All right, now notice that in previous lessons that we've had, the denominator, you see the square root of 25, that denominator was a perfect square. And so when I take the square root of 25, we got the denominator to be 5. Now remember in a previous lesson, we learned about rational and irrational numbers. So now we know that 5 is a rational number, okay? And so when I look at number 1, 2 is not a perfect square, and I cannot simplify the square root of 2. But remember, the square root of 2 is an irrational number. So based on a previous lesson, just make sure you go back to that previous lesson to review rational and irrational numbers. So based on that previous lesson, the square root of 2 is irrational. In math, we don't want any irrational numbers in our denominator when we're talking about radicals. So the denominators, when we talk about radicals, we want the denominator to be a rational number. So we need the denominator to be a rational number. Okay, right now, rational number. So right now, it's an irrational number. Okay, and so what we're going to do to make it a rational number is we're going to use the idea of rationalizing the denominator. So the directions will say divide, or it may say rationalize the denominator. So rationalize the denominator. So that's that new idea here. Rationalize the denominator. Now make sure you understand what that means. So when you're told to rationalize the denominator, notice in the word rationalize is the word rational. So you want to make that denominator a rational number. And remember, we're dealing with square roots. So we're dealing with square roots. It's very easy to rationalize the denominator. And all you do to rationalize that denominator, to make that denominator a rational number, is to multiply. I'm going to go ahead and rewrite it over. Is to multiply. Now remember, you need to make you're making this expression equivalent, but you're going to change what it looks like, so that way you can get this denominator to be a rational number. So if you want to rationalize the denominator, meaning you want to get this denominator to be a rational number, right now it's rational, all you do is multiply the numerator and denominator by that radical. So that radical here is the square root of 2. And remember, the square root of 2 divided by the square root of 2, that's 1. So 1 times this is still that. So these two expressions are still equivalent, okay? But I'm going to change what it looks like. So now I have 5 times the square root of 2 divided by, and then the square root of 2 times the square root of 2 is the square root of 4, right? But we know now that the square root of 4, that 4 is a perfect square, so the square root of 4 is 2. So I get 5 square root of 2 divided by 2. And so now I've rationalized the denominator. I've made that denominator a rational number. Okay? So again, whenever you have a radical in the denominator, remember we're dealing with square roots here. Square roots are easier to deal with than cube roots and so forth. So when you have a square root in the denominator, to rationalize the denominator, you just multiply the numerator and the denominator by that radical, by that square root. All right, now remember, these are equivalent expressions, because this is 1 right here, and 1 times 5 divided by the square root of 2 is still 5 divided by the square root of 2. These are all equivalent, it just looks different. All right? Okay, so notice now I've rationalized the denominator because the denominator is a rational number, and that's what that means. Okay? All right, so let's go to number 2. Number 2, we have the square root of 7 divided by the square root of 3. All right? Well, so notice the denominator is an irrational number. All right, that's an irrational number. 3 is not a perfect square, so it's going to be an irrational number. And so to rationalize the denominator, I'm going to multiply. I'm going to rewrite this over. I'm going to multiply both numerator and denominator by that radical. So square root of 3, square root of 3. And then I'm just going to rewrite it as one radical. The square root of 7 times the square root of 3, remember that's the square root of 21. And then the square root of 3 times the square root of 3, that's the square root of 9. Now, most students will skip this step. They know that the square root of 3 times the square root of 3, based on your experiences in previous lessons and worksheets, that the square root of 3 times the square root of 3 is just 3. So you can just write the number 3 here. All right. Now, be careful. Don't say 3 goes into 21 7 times, because that's not a 21. Make sure you understand. So some students will do this. So it's incorrect to do this. All right. So don't say that's 7. That's wrong. Okay, because that's not 21. That's the square root of 21. And if you take your calculator and you take the square root of 21, you're going to see that's not 21, right? Okay, so square root of 21 is approximately equal to 4.6. All right, so you have this irrational number. So be careful. Some students will do that. They won't think. They think that the square root of 21 divided by 3, you can still reduce that. You can't, because that's not 21. That's the square root of 21. All right. So just be careful. But I did rationalize the denominator, so now notice my denominator is a rational number. Okay? All right, let's look at number 3. So number 3, let's suppose you have the square root of 8 divided by 5. The square root of 8 divided by 5. Well, so I know from previous lessons I can write this as the square root of 8 divided by the square root of 5, right? And so to rationalize the denominator, I'm going to go ahead and rewrite this over. I'm going to go ahead and multiply both numerator and denominator by the square root of 5. And so now I'm going to go ahead and multiply the numerator. So the square root of 8 times the square root of 5 is the square root of 40. And then the square root of 5 times the square root of 5 is just 5, because the square root of 25, which is 5. But remember, you need to simplify your radicals. So when you get to this point, if you leave this as your answer, even though you've rationalized the denominator, you're not going to get full credit because you forgot to simplify your radicals. Always simplify your radicals in this course. And so 40, the largest perfect square that goes into 40 is 4. So this becomes the square root of 4 times the square root of 10 divided by 5. And the square root of 4 is 2. So your answer is 2 square root of 10 divided by 5. Okay? All right. So rationalize the denominator. My final answer. My denominator is a rational number. And I've simplified any radicals that are present. Okay, number 4. Suppose number 4, you have, let's say, 6 divided by the square root of 12. 6 divided by the square root of 12. All right. Now, I'm based on what we've been doing. So you see a square root in the denominator. You know that that's an irrational number because 12 is not a perfect square. So that's an irrational number. And so then you're going to say, well, I'm going to do what I did in the previous 3 problems. I'm just going to go ahead and multiply both the numerator and denominator by the square root of 12. Okay, that's fine. You can do that. That's nothing wrong with that. That's what we've been doing, right? And so you get 6 square root of 12, right, as 1. And then the square root of 12 times the square root of 12, that's the square root of 144, which is just 12, right? That's just 12. All right, so remember the square root of 12 times the square root of 12 is the square root of 144, which is 12. So remember the whole, whenever you multiply a square root by itself, you're no longer going to have that square root anymore. It's just going to be that radicand. All right, square root of 12 and square root of 12 is just 12. Okay, the square root of 5 and square root of 5 is just 5. All right, okay, but several things you can see here. For one thing, you can reduce the 6 and the 12, right? And then the other thing here is that you can simplify the radicals, the radical here. All right, you can simplify the square root. So a couple of things more you got to do. All right, so if you want to reduce first, you can. So you can say 6 into 6 is 1, 6 into 12 is 2. So you get the square root of 12 divided by 2, right? And now let's go ahead and simplify the square root of 12. So I'm going to go off to the side and do that. So the largest perfect square that goes into 12 is 4. So I get the square root of 4 times the square root of 3. And the square root of 4 is 2. So you get 2 square root of 3. So that's the numerator. So you get 2 square root of 3 divided by 2. And then notice also I can reduce even further, right? So these 2's divide out, and all you have is the square root of 3 as your answer. All right? And notice that I did rationalize the denominator because notice that this is now a rational number, this is a rational number, 1's a rational number. All right, so remember you're left with a factor 1 down here, so that's a rational number. All right, so it's okay for the numerator to be irrational. See, the numerator is irrational, but the denominator is a rational number. All right, now I want to say this. Someone else could have done this. I just want you to notice this. I'm going to go back and rewrite 6 divided by square root of 12. So 6 divided by square root of 12. What we did first was we multiplied both numerator and denominator by that square root. Someone else could have done this first. You could have simplified the radical first. So in other words, remember the square root of 12 is 4 times square root of 4 times square root of 3, which is 2 square root of 3. So in other words, I could have said, well, that's going to be 6 divided by 2 square root of 3, right? And then you could have reduced at that point, right? You could have reduced. You could have said 2 divided by 2 is 1. 6 divided by 2 is 3, so you get 3 divided by the square root of 3. And then let's go ahead and rationalize the denominator. So when I rationalize the denominator, I'm going to go ahead and rewrite this over. So I'm going to go ahead and multiply both numerator and denominator by that square root of 3. And so I get 3 square root of 3 divided by, and then the square root of 3 times the square root of 3 is the square root of 9, which is just 3. And then now these 3's divide out. And so you just get square root of 3. All right. So regardless of which approach you take, you get the same answer. So you can simplify your radical first, or you can simplify it as you go along. Okay. So it's up to you how you deal with this, but knowing these different ideas here does help you in terms of having enough skills to be able to do future concepts. All right, so that's number 4. Okay, let's look at number 5. Now, number 5, let's suppose we had this. Okay, so we have negative 2 divided by 3 square root of 7. Negative 2 divided by 3 square root of 7. So notice that I cannot simplify the square root of 7 even if I wanted to, right? So you cannot simplify the square root of 7. But 3 square root of 7 is an irrational number. All right, so I have to rationalize this denominator. Now remember what we said, and we're gonna do it both ways. So you can remember to rationalize the denominator. You see that square root of 7 is my issue here. To get that square root out of that denominator, I'm going to go ahead and rewrite this over. I can just multiply both numerator and denominator by that square root of 7. All right, and that's fine. You may say, well, what about that 3? Well, that's okay. Leave it alone. You're just trying to make this denominator a rational number. You don't want a square root in the denominator. All right, and so by doing that, I will eventually have a rational number down here, because watch. So this becomes negative 2 square root of 7 divided by 3 times, and then the square root of 7 times the square root of 7 is 7. And so this becomes negative 2 square root of 7 divided by 21, and 21 is a rational number. See that? And then I cannot simplify the radical, and I cannot reduce, so there's your answer. That's all you do. Now, I want to say one other thing about this. So I'm going to go rewrite this problem over. I'm going to put an R here. So I get negative 2 divided by 3 square root of 7. Some students, what they'll do whenever they want to rationalize the denominator, they'll just go ahead and multiply both numerator and denominator by that denominator. So they'll say, oh, I'm going to multiply both numerator and denominator by 3 square root of 7. Nothing wrong with that either. You just got to be careful. It becomes a little bit more complicated, not a lot, but you have another little thing to deal with. So in the numerator, you see you have negative 2 times 3 is a negative 6. So you have negative 6 square root of 7. Now be careful in the denominator. 3 times 3 is 9. Okay? And the square root of 7 times the square root of 7 is 7. Square root of 49, which is 7. So then this becomes negative 6 square root of 7 divided by, and then 9 times 7 is 63. And then go ahead and reduce. So the numerator, the negative 6 and the 63 are both divisible by 3. So let me go ahead and rewrite this over. So 6 divided by 3 is 2, and then 63 divided by 3 is 21. So the answer then is negative 2 square root of 7 divided by 21. And that's what we got here. All right. So what my inclination is always, if I see a square root in the denominator, even if there's a number in front of it, okay, I would just go ahead and multiply both numerator and denominator by that square root. So that way you don't have to deal with all these other factors appearing. All right, so just be aware of these different little things that you can do, and knowing all this does help. Okay, so let's look at number 6. So number 6, let's suppose we had 5 divided by the square root of 3y. Okay, so now we're going to have some variables involved. That's okay. We can deal with that. We've had enough experience in previous lessons to deal with radicals with variables. So remember, I want to get rid of the square root that's in the denominator, and so I'm going to go ahead and multiply both numerator and denominator by that square root of 3y. So I'm going to go ahead and rewrite this over. So times the square root of 3y times the square root of 3y. And so now I have 5 square root of 3y. And remember, the square root of 3y times the square root of 3y, based on our discussions and also today and also previous lessons, that's just 3y, right? That's just 3y. And make sure you understand that. The square root of 3y times the square root of 3y, when you multiply radicals that have the same index. In this case, they do. They're both 2, so hence the idea that square root, you you can write as one radical. So 3 times 3 is 9, so you get the square root of 9, and then y times y is y squared. And from previous lessons, you know that that's going to be the square root of 9 is 3, and the square root of y squared is y, because 3y times itself is 9y squared. All right. So just remember that in any square root times itself is that radicand. All right, and it cannot reduce any further, so you're done. And don't say I can divide those y's, because that's not a y here. That's a square root of y. That's different. Okay. So there's your answer. You rationalize the denominator, meaning you no longer have a square root in the denominator. You have a rational expression. Okay. Number 7. Number 7. Let's suppose we had this in number 7. We have the square root of 27 divided by 2a to the 7th power. All right, so the square root of 27 divided by 2a to the 7th power. Okay, so now it looks a little bit more complicated than all the others we've had, but we can do with it. We can deal with this. So I'm going to rewrite this using a quotient rule for radicals as the square root of 27 divided by the square root of 2a to the 7th. Okay? All right, now remember, so be a little bit careful with this one. So you see I have a to the 7th here, right? And remember, whenever you have a variable raised to a power and you want to simplify this, remember the exponent here is 7, right? And so if I want to get rid of that square root, then I really need this to be an even number. And you're going to go opposite of what you've done in the past. So you're gonna say what's the next number greater than 7 that's divisible by 2. And so the answer is 8. And so you're going to multiply both numerator and denominator by a square root of a. All right, so this is a little bit more complicated, so listen carefully again. I'm going to go over this again. Let's go ahead and let's do this. Let's look at an easier problem. Then we'll come back to that. All right. So because that square root of 2 is making it a little bit more complicated. So let's make this number 7. Let's make this number 7. So number 7. Let's suppose we had 5 divided by the square root of x to the 3rd power. 5 divided by the square root of x to the 3rd power. Okay, a couple of things you can do. You could simplify the square root of x to the 3rd first, and we know how to do that. We know that the square root of x to the 3rd is the square root of x squared times the square root of x, based on our experience before, right? Okay, and so the square root of x squared is x, so you get x squared of x. So that's that denominator. So this becomes 5 divided by x squared of x. Okay. And so now, remember, you see that square root of x, right? So let's go ahead and multiply both numerator and denominator by the square root of x. Don't do x squared of x, just do square root of x. Just do that. So 5 divided by x squared of x, and you can multiply both numerator and denominator by the square root of x. And so I get 5 square root of x in the numerator divided by, now be careful, this is x times, and then the square root of x times the square root of x is just x, because remember that's the square root of x squared, which is just x. So then I get 5 square root of x divided by x squared, and there's your answer. You're done. Now, here's what I was trying to get across in the previous problem. All right, so listen carefully. I'm going to rewrite this over. So 5 divided by the square root of x cubed. Now, you could have, you see how we simplified first? See how we simplified first? In this case, it's probably easier to simplify first because you kind of understand some of the things that we've done previously. What you could have done was this. You see, this is a 3, right? If this was a 4, the next higher number, the next larger number that's divisible by 2, so that's 4. So if I were to multiply both numerator and denominator by the square root of x, that would get that to be 3 plus 1 is 4. So that would simplify this radical, and that would no longer have a radical in the denominator any longer. So in other words, I would get 5 square root of x divided by, and then this is the square root of x to the 4th, right? x cubed times x to the fourth, and then the square root of x to the fourth is x squared. All right, and so notice you get the same answer. Now let's go back and make this. I'm going to go back and make this number 9. So I'm going to change this over. I'll make this number 9. Number 8, I'm sorry, number 8. So you have the square root of 27 divided by 2a to the 7th power. All right, so we're going to do it both ways. We're going to do it this way, and we're going to do it this way as well. So let's go ahead and rewrite this as the square root of 27 divided by the square root of 2a to the 7th. Now let's go ahead and simplify the square root of 2a to the 7th, because that's what you know. You've had that in the past. So the square root of 2a to the 7th, square root of 2a to the 7th, we know is the square root of 2 times the square root of a to the 7th, right? And then I cannot simplify the square root of 2, but I can simplify the square root of a to the 7th. And so that's the square root of 2. And then when we simplify the square root of a to the 7th, the largest whole number less than 7 that's divisible by 2 is 6. So we said a to the 6 times the square root of a. So the square root of a to the 7th is this. And now let's simplify. So we have the square root of 2. The square root of a to the 6 is a to the 3rd power, because a to the 3rd times itself is a to the 6th. And then the square root of a. And then we rewrote this as the square root of 2a. Remember that? So it'll be a cubed square root of 2a. So that is the denominator. So the denominator is a cubed square root of 2a. But I can also simplify the numerator. So let's simplify the numerator. So when I simplify the numerator, the square root of 27 is the square root of 9 to the square root of 3. The largest whole number, the largest perfect square that goes into 27 is 9. And the square root of 9 is 3, so you get 3 square root of 3. So that's the numerator, 3 square root of 3. All right, so that's where I'm at. So all I did was I used concepts from previous lessons to get us to simplify the square root of 2a to the 7th. And so I get a to the 3rd times the square root of 2a. And then the square root of 27 we know is 3 square root of 3. All right, now let's go ahead and get rid of that square root. So remember, don't multiply numerator and denominator by the denominator. Just multiply by that square root. If you do the denominator, it makes things so much more complicated for you. Just do the square root. Okay, so I'm going to go ahead and rewrite this over. So I get 3 square root of 3, 3 times the square root of 3, that's just 3 now, divided by a cubed times the square root of 2a. So I'm going to say times the square root of 2a times the square root of 2a. All right, now let's go ahead and multiply the numerators and multiply the denominators. So in the numerator, I get 3. The square root of 3 times the square root of 2a is the square root of 6a. 3 times 2 is 6. So the square root of 6a divided by a cubed times, and remember the square root of 2a times the square root of 2a is 2a, right? But look, I can simplify the denominator further. A cubed times a is a to the 4th. So I get 3 square root of 6a divided by 2a to the 4th, and you are done. That's the answer. That's the answer. Okay, so when dealing with square roots, and there are variables in that denominator, it is probably easier for you since you've learned about how to simplify radicals that have variables raised to power, and then come back and then rationalize what's left. All right, so that's the way I would have done that one. Okay. Now let's look at number 9. So this is number 9. So number 9, let's suppose we have the square root of 20x divided by the square root of 2y. Square root of 20x divided by the square root of 2y. Okay, so even though you notice, hey, I can simplify the square root of 20, you can do that now, or you can just wait and see what happens later. Some of you, most students, will go ahead for right now and just rationalize that denominator. So in other words, they will say, I'm going to go ahead and rewrite this over. They will say, oh, I'm going to multiply both numerator and denominator by that radical. Okay, That's what I would do. And so now let's go ahead and multiply the numerators. So the square root of 20x times the square root of 2y is the square root of 40. 20 times 2 is 40, xy. Square root of 40, xy. Divided by, and remember the square root of 2y times the square root of 2y is 2y. Okay? But remember, even though you no longer have a square root in the denominator, so you've rationalized the denominator, notice though I can simplify the square root of 40. So let's go off to the side and simplify the square root of 40. So I get the square root of 40 times the square root of x and the square root of y, right? That's what this is. So the square root of 40, the largest perfect square that goes into 40 is 4. So you get square root of 4, square root of 10, square root of x, square root of y. And so the square root of 4 is 2, so I get 2, and then this right here becomes 10x, the square root of 10xy. And so that's your numerator. And notice what happens now. Watch. You get 2 square root of 10xy divided by 2y. You can simplify. Make sure you reduce. Make sure you do that. And so the answer that you would give me then would be the square root of 10xy divided by y. Okay? And again, don't reduce the y's because that's not a y in the numerator. That's the square root of y. Okay, that's different. All right, that was number 10. Now, if you wanted to, I want to show you, just to show. I'm not going to keep doing that because of the time constraint we have. But if you wanted to simplify the square root of 20 first, you could. So let me go ahead and rewrite it over. So square root of 20x divided by the square root of 2y. So if you want to simplify the square root of 20, square root of 20 times the square root of x, that's the numerator. And so 4 is the largest perfect square that goes into 20. So you get square root of 4, square root of 5, square root of x. So you get 2, and then this is square root of 5x, right? So that's going to be the numerator. So 2 square root of 5x divided by square root of 2y. And now let's go ahead and rationalize the denominator. So we're going to multiply both numerator and denominator by the square root of 2y. And notice what we get. We get 2. The square root of 5x times the square root of 2y is the square root of 10xy divided by, and then the square root of 2y times the square root of 2y is just 2y. And see, that's what we had here. And then you reduce, and so you get the square root of 10xy divided by y. Okay? So it doesn't matter whether you simplify at the beginning and then rationalize, or you rationalize first and then simplify. Okay? It does not matter. All right. So number 10. Number 10, let's suppose we have this in number 10. We have the square root of 45 divided by the square root of y to the 5th. Okay? Square root of 45 divided by the square root of y to the 5th. Now, so based on our discussions that we've had, so some of you are going to say, well, I'm going to go ahead and simplify the square root of y to the 5th first. You definitely can do that. That's fine. So the square root of y to the 5th would be the square root of y to the 4th, right? Times the square root of y. And so the square root of y to the 4th is y squared, square root of y. So that's your denominator. So that's that denominator. And so then you might say, well, can I go ahead and simplify the square root of 45 also? Yes, you can. You can definitely do that. So the square root of 45, we know, is the square root of 9 times the square root of 5. And then the square root of 9 is 3, so you get 3 square root of 5. 3 square root of 5, right? So 3 square root of 5. All right, so that's where I'm at. Okay, so I simplified this and it looks like this. But remember, you're trying to rationalize the denominator. Your final answer needs to be rationalized. So you see that square root, don't multiply numerator and denominator by the denominator. Although you can, it's going to make things more difficult for you. See, all you're trying to do is get rid of that square root. So I'm going to go ahead and rewrite this over. So all you do is just multiply both numerator and denominator by that square root of y. And that will rationalize the denominator for you. So you get 3, and then the square root of 5 and the square root of y is the square root of 5y. And then be careful, you have that y squared here, times, and then the square root of y times the square root of y is y. But you got to simplify this. Y squared times y is y cubed. So you get 3 square root of 5y divided by y cubed. And there's your answer. Okay? Notice that I no longer have a square root, a radical in the denominator. Now, I want to come back and I want to do number 10 again, but I want to show you something. Okay, now you see how, and the reason I didn't do it in the other one, let me go ahead and find it. The reason I'm about to show you something, and the reason that what I'm about to show you I did not do here was because of that extra 2 that was there. And it would have made things a little bit more confusing for you. But I want you to notice something. You see that's a 5, right? And so if this was a 6, see the next larger number that's divisible by 2, if that was a 6, then I know that the square root of y to the 6 is y to the third, right? And so now I would no longer have a square root in the denominator. So what you can do is this. I'm going to rewrite this over. If you know that right now it's a 5, if this was a 6, then I would the square root would no longer be there. Then go ahead and say, well, I'm going to multiply both numerator and denominator by the square root of y, because y to the 5th times y is y to the 6th, right? So this becomes the square root of 45y divided by the square root of y to the 6th. And then simplifying the square root of y to the 6th, we get y to the third, which is the denominator. And then simplifying the square root of 45y, the square root of 45y becomes the square root of 45 times the square root of y, right? And then so the largest perfect square that goes into 45 is 9, so you get the square root of 9, square root of 5, square root of y. And so you get 3, and then this is just the square root of 5y. Right? So I just wanted to show you that if it's simple enough to where you can do this, then go and do that. All right. Most students, though, will probably stick to this approach because that's something something they've had in the past that helps them to understand this better. Okay, so that's number 10. So let's look at number 11. So number 11, let's suppose you have this. In number 11, we have the square root of 3a divided by 80. The square root of 3a divided by 80. Okay, so let's go ahead and rewrite this as the square root of 3a using the quotient rule divided by the square root of 80. And some of you may say, well, could I simplify the square root of 80 first? Yeah, you can, and we'll do that. And some of you may say, well, I'm just going to go ahead and multiply both the numerator and the denominator by the square root of 80. You can do that as well. So I'm going to go ahead and rewrite this over. So you can say times the square root of 80 times the square root of 80, right? And so then you would say 3 times 80 is 240, okay? So you get 240 times 8, the square root of that. And then the square root of 80 times the square root of 80 is just 80. Okay, now we got to simplify the numerator. So then you got to come back and you got to say, well, let me find the largest perfect square that goes into 240. So you might say, well, I'm going to try 4 first since 4 is a perfect square. Okay, no big deal. So 240 divided by 4 equals 60. Okay, but the question is 4 the largest? Is there another perfect square that goes into 60? All right. So you got to think about about 60. So what are the factors of 60 if you need to do that? And so as you think about it, you notice, hey, 60 is 2 times 30, right? So let me write that out. So you know that 60 is 2 times 30. And you know that 30 is 2 times 15. So hey, 4 will go into 60 as well. So you have this 4, and you have the perfect square of 4 that goes into 60. So 4 times 4 is 16. So it looks like 16 is the largest perfect square. So let's do that. Let's try that again. So 240 divided by 16 is 15. And the only perfect square that goes into 15 is 1. And so I'm going to rewrite 240 as the square root of 16 times the square root of 15 times the square root of a. And so the square root of 16 is 4, so you get the square root 4 times the square root of 15a. So that is the numerator. So 4 square root of 15a divided by 80, and then reduce 4 and 80 now. So 4 to 4 is 1, 80 divided by 4 is 20. So you get the square root of 15a divided by 20. And so notice you rationalize the denominator. You no longer have a radical in the denominator. All right. Now, remember what we said. So someone may have said, well, can I simplify the square root of 80 first before I rationalize? Yep, you can do that. So let's do that. So you get the square root of 3a divided by 80, and we know about the quotient rule for radicals. I can write it as square root of 3a divided by the square root of 80. And let's go off to the side and figure out what the square root of 80 is simplified. So the largest perfect square that goes into 80, let's try 4. Let's see if 4 is the largest. So I get 80 divided by 4 is 20. And I know that 4 is divisible into 20. So 4 times 4 is 16. So it looks like 16 is going to be the largest perfect square. So I get the square root of 16 times, okay, so 80 divided by 16 gives us 5 times square root of 5. So that'll be 4 square root of 5. So that's going to be your denominator now, 4 square root of 5. So I get, let me do that here. So I get the square root of 3a divided by 4 square root of 5. And now let's go ahead and rationalize the denominator. So I'm going to multiply both numerator and denominator by that square root of 5. So times the square root of 5 times the square root of 5. And so the square root of 3a times the square root of 5, remember when you multiply in radicals and the indices are the same, you write as one radical. You multiply the radicands together, 3a times 5 is 15a. And then 4 times the square root of 5 and the square root of 5 is 5, okay? And so you make this look a little bit better. 4 times 5 is 20, and there's your answer. Okay? So you see, sometimes, and you need to be aware of these things, sometimes it is easier to simplify the radical before you rationalize. All right, so see how it became a little bit more complicated here because you had to determine, well, what's the largest perfect square that goes into 240, and then you have to reduce eventually still. All right, so just think about these little different scenarios that you can see. All right, let's do one more. Let's do number 12. So number 12, let's suppose we had, let's see, AB divided by the, 6 times the square root of c cubed. All right, so AB divided by 6 divided by the square root of c cubed. All right, so let's think about the different approaches we can take. So some of you may say, well, the square root of c cubed, the fact that I have a variable in the denominator raised to a power, that throws me off. So let me go ahead and simplify this because I know from previous lessons how to do that. So I know that I can simplify this as the square root of c squared times the square root of c, and the square root of c squared is c. So I get c squared of c. So that's the denominator. So I'm going to rewrite the square root of c cubed as this now. So I get ab divided by 6c square root of c. And then you say, well, okay, I simplify this. There's a square root in the denominator. I know I want to rationalize this denominator. So I'm just going to go ahead and let me go ahead and rewrite this over. So then you're thinking, well, I'm just going to go ahead and to get rid of that square root of c, I'm going to multiply both numerator and denominator by the square root of c. Okay, very good. That's what I would do. So you get ab square root of c divided by 6c, now be careful, 6c, times, and then multiply this out. The square root of c times the square root of c is just c. Now go ahead and simplify this further. You know that c times c is c squared, so your answer then is ab times the square root of c divided by 6c squared. And remember, be careful. I keep telling you, don't reduce the c that you see here because that's not c, that's the square root of c. Okay, so be careful. And so there's your answer. You're done. Now, let me do this another way. So knowing the different approaches can help you to understand things a little bit better. So you know that you cannot simplify the square root of c cubed. Hence, that's why you did this. But I know that if that was a 4, right? If that was a 4, then I know that the square root of c to the 4th is c squared. based on previous lessons, because c squared times itself is c to the fourth. So in order to get c to the fourth here, then let me go ahead and rewrite this over just to kind of save that little part here. All I need to do is multiply both numerator and denominator by the square root of c, because c cubed times c is c to the fourth, right? And so then I get a, b, c, the square root of c, ab square root of c, divided by 6 times the square root of, and then the square root of c cubed times the square root of c is the square root of c to the fourth, and we know the square root of c to the fourth is c squared, so I get a, b square root of c divided by 6c squared, and there's your answer. Okay, so you see the different approaches, the different paths that you can take to get to that same answer. All right, and that's important to see. All right. Okay, so that is that is the lesson on dividing radicals by rationalizing the denominator.